Today, we're going to be working on some more inverse work to figure out, do we have inverses, how to manipulate your x and y values, finding some inverse functions, and verifying. So if we're trying to find the reverse of each relation of each function, we're going to take these groups of your coordinates, and we just get to reverse the position of your x and y, because inverses are reflections of one another through the xy plane. So we get to reverse the coordinates. So -3, 1 would be your first point, and 3 comma -2 would be your second, and 1 comma 5, and 4 comma 6. And given these coordinates, we can tell if it is the inverse or if it will have an inverse as long as your y values do not repeat here. So this would be the new relation. And if you wanted to try it out here in example 2, feel free to do that one. And when it says finding the inverse equation, I'll just do a few here. I'll do number 3, number 11, number 14, excuse me, perhaps number 16. So do just a few different types here. So in order to find your inverse function equation is that we first, as we did here, switch your x's and your y's. So if we had a y, it's now an x, and if we have an x, it's now a y value. So now we want to go and solve for y. We want to get y alone. So the first thing we want to do is subtract 2 to the other side to get your y term alone. We want to do that each and every time. So that means for all of these over here, we're going to subtract or add those values over. Then we get to divide each term by 3. So you have y is equal to x minus 2 over 3, or if you'd like to break it up so that each term has a division by 3, you could certainly do so. And the last thing is by actually going ahead and writing your inverse. Funky looking 3. There we go. This is the inverse of this one. Now I would go ahead and practice those ones with these next linear problems. These steps are the exact same. Add or subtract to the other side, divide by your coefficient, or multiply by your coefficient. If it's any sort of what are these called, a fraction, you can multiply by the reciprocal, and this also being negative, you can multiply out that negative, but that way everything will cancel. So let's look at number 11. So switching your x's and y's first, subtract your 5, and notice that's the same step as we've done before. Now to undo a square, we're going to square root both sides. Y is equal to square root of x minus 5, and we do not need to add the plus or minus symbol since we're not actively looking for solutions. So now we have y equals the square root of x minus 5. Last thing we're going to do is we're actually going to write the inverse is equal to x minus 5. And most likely for these following ones, we would have to restrict your domain. Just as your domain here is restricted, your domain of this value, we're going to set the parenthesis or the square root greater than or equal to 0, because underneath the square root, you can be 0, square root of 0, 0, but you cannot be any sort of negative number. So negatives are not able to go underneath the square root. Therefore, setting it greater than or equal to 0, and then solving for x. So your threshold value here would be a 5. So 5 minus 5 is going to be the square root of 0, which is okay. But anything less than 5, so let's say it's 4, will provide us with a negative response, which is what we don't want to happen. So your domain on this one is going to be when x is 5 or greater. Whereas for your range, if that's your domain, your range here is going from 5 to infinity. And your domain here would have, it would have had to have been capped off, right? So for this one, your range of this function, depending on your familiarity with the square root graph and your translation, this graph for this one would have just been moved over to the right by 5. So your domain of this graph should go from 5 to infinity, as it does here. And your range goes from 0, you have the point here, 5, 0. It goes from 0 to infinity. So your range from 0 to infinity, meaning that your range and your domain here goes from 0 to infinity. The reason why we can flip-flop these is because we flipped your x's and y's originally. Because the graph of this one is just your parabola that has been moved up by 5. However, because it does not pass your vertical line or your horizontal line test, we've had to then cap off your domain and your range here. So your domain here goes from 0 to infinity, and your range goes from 5 to infinity. And those would be their natural, or those would be their inverse values. Now let's do the same for 14. Again, we're under the implied restriction. You'll see your actual restriction here, right? But we're under the impression that these are going to have some sort of an inverse. So we have x is equal to y minus 6 squared. Now this y term is all alone to one side, so that means we can go ahead and square root both sides. Y minus 6, so we can say x plus 6 is equal to y. So your inverse function of x is equal to the square root of x plus 6. Again, we would have to provide some sort of restriction because your domain here, your graph, has just been translated over here to the right by 6, which again, it does not pass your horizontal line test. So we've had to cap off your domain at your point 6, 0, which means your domain of this one is going from 6 to infinity, and your range here is going from 0 to infinity. And that also will translate over here. Your domain, if we set x greater than or equal to 0, because it's underneath the square root sign, suggests that we just go from the values of 0 to infinity. Your domain is the same as your range from the original. And your range is the opposite. Your range should go from 6 to infinity. This could be coming from the domain of the original. We switch those two values. Now let's do it one more time with 16. Y becomes x becomes y. And they're telling us that your range here is going from y is greater than or equal to 0. So now let's go ahead and solve. So now we have x squared is equal to y plus 5. Subtract 5 from both sides, you get x squared minus 5 is equal to y, or your f inverse, meaning that your domain here is now your range from 0 to infinity. And your range of this one is going to be your domain of this one. Your domain of this one, we set again greater than or equal to 0. So greater than or equal to -5. So we go from -5 to infinity, which is the same as your range over here. If you're having trouble with your restrictions, please watch that restricted domain worksheet that we did previously. So now let's take a look at verifying inverses. Verifying inverses, I'll only do a couple, probably 19 and probably 22. It just says we have to plug in one inverse or one function into the other. So I'm going to go ahead and plug g of x into your f of x value. So f of g of x is equal to f of x minus 6. So I'm going to plug in an x minus 6 anywhere I see my x value. So x minus 6, that used to be my x plus 6. I simplify and get x. So that part is really good because I want to get an x value out. And if I do the same thing, but for the other one, I'm going to plug in f of x into g of x. So taking my g or f and putting it into g. My f is x plus 6. Now I'm going to replace this x value with an x plus 6 minus the 6. And again, those are going to cancel and we'll get x. As long as they both come out to x, these are inverses of one another. Doing the same with your next one, we're going to take f of g. We're inserting x plus 7 over 2 into where there is a x value. So it says 2 times x plus 7 over 2 minus 7. And our 2's cancel. So we're left with x plus 7 minus 7, which will then in turn cancel. We're left with x. So far, so good. We do the same, but with your g and your f. So anywhere there is an x, we're going to replace it with f of x. So it says 2x minus 7 plus 7 all over 2. Again, this is where your x was. This allows us to cancel out the 7, cancel out the 2, and we're left with x. So again, these two are inverses of one another. Doing the same for 20, 24, 21, 23, just by plugging in one of those following. If you're having a hard time with this, please watch 4.3, where we talk about compositional functions. Now, lastly, we are going to go ahead and start to graph your inverses. I'll start with 28 here. When it comes to graphing your inverse, we're going to take all of your nice points that match up correctly. This being 0, 0, 1, 1, and 4, 2. And just as we did in the very first one, we are going to flip-flop your x's and your y's. So for your next graph, 0, 0 remains the same, 1, 1 remains the same, but 4, 2 becomes 2, 4. So 2, 4, if I were to plot that, is all the way up here. And if I'm trying to connect these dots, they're going to go, oops, they're going to go up like this. So this is your inverse. This is 2, 4. Now, if we've done it correctly, we should have a mirrored line over the y equals x line. It just means that we're going to take all of these lines and reflect it over to the other side. So let's do it again over here. We'll take this point here. This was 0, 3, and perhaps this one is negative 2, 4. We'll do another one, 2, 2, and 4, 1. We're going to switch their x and y values. So this one is now 3, 0. So we got 1 point here. We now have 2, 2. We're going to have 1, 4. So 1, 4 up here. And 4, negative 2. So 4, negative 2. Being right here. It's going to come down. I'm going to try that one again. 1, 2, 4. So should have all of those points being reflected over, once more, your XY. So what happens here is reflected down here. What happens here is reflected up here. And again, just looking at the point 0, 3, we should have 3, 0. 4, 1 becomes 1, 4. 2, 4, or negative 2, 4 becomes 4, negative 2. And I think you guys can do the rest.